In the last example, we saw a denominator that was composed of just two factors. Now we got something a little bit more going on here. Now, nothing to be concerned about, because right now we're going to focus on having just linear factors. So x squared plus 5x plus 6 will factor as x plus 2 times x plus 3. So since we have three distinct factors, we're going to have three fractions here that we're going to try to break this guy down into. So one of these is going to be over x plus 1, one is over x plus 2, and one is over x plus 3. And we need to find what those numerators are, so we'll just call them a, b, and c. So kind of doing what we did in the last example, we want to put in those missing factors and then see what we have once everybody has the same denominator. So we'll see here that we are missing x plus 2, x plus 3, so we put that in both the numerator and denominator. This guy's missing x plus 1 and x plus 3. And the last guy is missing the factors of x plus 2 and x plus 1. All right, so everybody now has the same factors in the denominator, so we're going to wipe all that out, and we're going to see what we have left. Now I'm going to rewrite this a little bit differently. I'm going to put the unknowns here on the left, so a times x plus 2, x plus 3, plus b times x plus 1, x plus 3, plus c times x plus 1, x plus 2, is equal to the other numerator, x squared minus x minus 8. So two ways we could do this. We could create a system of equations, but we would have to multiply everything out and then see, okay, what are all the coefficients that make up the values for coefficient for x squared, for x, and the constant. Again, it'll still work, but I think it'll be easier if we pick and choose the values of x that we plug in here. So let's start with this. If I say x equals negative 1, with x being equal to negative 1, this guy's going to go away, and this guy's also going to go away because the x plus 1 factor, when you plug in negative 1, becomes 0, and 0 times the rest of that just goes away. And that's going to leave us with, I got to be careful about how I plug in because sometimes I get careless. So it's going to be a times, so negative 1 plus 2 is 1, negative 1 plus 3 is 2, okay? 0 and 0. On the right side, we end up with positive 1 when I square that. Negative times negative is positive 1 minus 8. All right, so we have 2. A equals negative 6. And A equals negative 3. All right, we are a third of the way there. Now, let's try a different value. So we did x equals negative 1 because that was the first one that would eliminate. The other critical value that we have is negative 2. And when I plug in negative 2, you'll see that negative 2 is going to kill this guy, and a negative 2 right here is going to make this guy go away as well. So all we need to do is plug in the negative 2 here and see what happens. So that's b times, that's negative 1 times 1. Plugging in negative 2 on the right side gives me a positive 4 plus 2 minus 8. So negative b equals negative 2. So b equals positive 2. All right, I'll take that. And then for the last one. Now, here's something you can do for the last one. You could use the other critical value that we have, which I think would actually be the best thing for you to do. But since you already know what A and B are, and you just need to know what C is, you could pick any value for X and plug it in, and then see what's left over. So we could say what happens when X is equal to 0, right? So when X equals 0, you'll have 2 times 3 times A, so it's going to be 6A plus 1 times 3, so that's 3B plus 2c equals, you plug in 0 on the right, you just have negative 8. But again, keep in mind the fact that we already know what is A and what is B. A is negative 3, so we end up with negative 18. B is 2, so plus 6 plus 2c equals negative 8. Negative 12 plus 2c equals negative 8. 2c equals 4, so c equals 2. You'll see that you would have ended up with the same thing had you plugged in the last critical value of negative 3. Plugging in negative 3 would have killed this guy and that guy. You would have worked it out for c, you plug in the negative 3 over here, and you should get the same thing. You know what? Let's just double check that to make sure, right? I always like to double check because, man, at my age, I keep doing bad stuff. So if x is negative 3, gone, what do we have here? So we have negative 3 and negative 3, so that's going to be c times negative 2 times negative 1. Plug in, negative 3 over here, so that's going to be 9 plus 3 minus 8. So we have 2c equals 12 minus 8 is 4. C is still equal to 2. So we have all of the pieces that we need. We have A, we have B, and we have C. So the last thing we need to do is to rewrite our fraction using these values that we have. So my fraction is equal to negative 3 over x plus 1 plus 2 over x plus 2 plus 2 over x plus 3. So we've broken it down piece by piece. And yeah, we should be good to go there. Hopefully that makes sense. Because now we're going to see in the next video what happens when you have a factor that's repeated more than once. What if there's a square? How do we handle that? Stick around.